Okay, so here's the rub, fellas. You're at another sunny day at the office. You've worked on dilute solutions and stuff on cannabis plants for many years, probably decades. You've gone to the sort of semi-intermediate, large scale sort of thing. You've done stuff in dustbins and everything there. Now it comes to having a play around with tissue culture, just to see if you can go between the two, you know, from the very dilute to the, you know, semi-ecological out in the real world sort of thing. But now you want to go from that to that, back to the real world, bring the real world back home into the tissue culture jar sort of thing. But you've got, you know, you want to see if you can actually transfer your sort of knowledge of how it's going on and the levels and things like that back down to an intermediate scale. You're probably going to have problems, but here's a little trick I'll show you. Say, well, for example, you've got some manganese, but that's too dilute. This is way too much. You want something that's in between, but how do you measure it out? So what you do is you take some talc, semi-inert from this sort of level sort of thing. You take yourself, you know, because now you're in the precision stage, like you've spent years working out, you know, dilutions, lower levels, upper levels, how much you can push it by, like a 1.5 grams before you kill the plant, before you burn the roots off your plant, things like that. So you go here, you just take like 9 of these, you know, do it the same. 4, 5, 6, 7, 8, 9. As I said, it doesn't have to be too accurate, because what you're trying to do is make a dilution, a physical dilution. Now, but see, that's the thing. You can actually, because you can do this over and over again. See, I know that will go right flat level with manganese and that spoon, because I know that's from experience. So I put that in, because if you really want to do it, you can actually measure out. So you take your talc and you measure out 100 spoons of talc, 1,000 spoons of talc, and you can weigh them all out, and then you can, you know, take it back to what is the average weight of a single spoon, or the average size of a single spoon. You can do all that. That's the power of the scientific method. The experiment doesn't have to be done today. It could have been done yesterday, it could be done tomorrow. You can always do another experiment. Most people seem to forget that. And then you just mix it around. You make a thorough mix. Maybe you want to do it for 5 minutes or something like that. And you just mix it around in this shot glass. And basically what you're making is a 1 in 10 dilution. You know, 9 parts of your filler and 1 part of the thing you want to dilute. So now, once it's mixed around thoroughly, and the thing about talc, it mixes really well, because of its electrostatic properties. It mixes things really well. Now, if you take out 1 spoon, you've got 1/10. If you take out 2 spoons, you've got 2/10. 3 spoons, 3/10. All the way up, 9 spoons, 9/10. If you took out all 10 spoons, you would have the original full spoon there, you see. So now, if I want to put 1/10 of a level spoon of manganese in there, I can easily do it now. All I have to do, say I want 3. So say let's just say I want 3/10 of a level spoon of manganese, because it compares between going from the very dilute to the extreme sort of thing. And I know I've worked out a rough level like that. Just say I've done that, something like that. Mix it around. Now what I do is get my spoon. I do the same thing again, same sort of size of spoon. 1, 2/10, 3/10. It's very simple, very quick, and then you can also put that aside if you want, because you now know that every spoon from there is 1/10. So if you want to make another jar, you now know you've got 7 lots of 1/10 in there to be able to use. So if you want to make another 2 jars, you'll be left over with 1 spoon left over. And also that's a safety check. If you, after you've done 3 jars, you should have 1 spoon left over. If you don't, well, then you haven't been too accurate with your measuring or your weighing out, and well, it's not really weighing out, volumetric separation. Anyway, that was just an example. So there you go. You've got 3/10 of your manganese, or 1 cubic centimetre of manganese sulfate in there now. So, and if you know the volume of the jar, you can start doing all your other little calculations if you want, if you haven't already done them many times in the past. See, that's the thing. What lies at the heart and core of the scientific method is reproducibility. Can it be done again, and how accurately can you reproduce it? And you know, don't let anyone stop you from doing science saying, oh, that's not accurate. You can do many experiments over time. Look at Darwin. See, Darwin's a fine example. He worked on 800 Drosera rotundifolia plants, you know, and we accept his research today because he worked on 800. I mean, it's easy to find 800 plants out in the bush usually. I mean, I could look at 800 glanduliciferal plants. So don't let anybody tell you that you can't do science, okay? And that your science doesn't count. That your science is Mickey Mouse. Well, it may be Mickey Mouse, but if you do Mickey Mouse over 100 years, it's called Walt Disney, okay? You got it? I hope so. Because some people overseas will put you down for doing something like this, that if you keep going, you'll get to the end of the journey and you'll be the one with the answer, and they'll be left with their asses swinging in the wind. Okay, over and out.